Okay, so now we need to talk about inverses of polynomials and radical functions with restricted domains. So remember when you have a polynomial with an even degree, it winds up going either up on both sides for the end behavior or down on both sides for the end behavior. Because with their even, left and right side both go the same way. But with that, that means they automatically fail the horizontal line test, which means no inverse. So what we do is we restrict the domain so that only part of the function remains. And then we have an inverse. Okay. But if it stays the original without the restrictions, we still have the fail. Okay. And then when we're working with a radical, the domain is restricted because we're not going to deal with the graphing of imaginaries. If you want to do that, take complex mathematics. It's awesome. I love it. Great field to study, but that's a tangent. Back to what we're doing. Okay, so here, remember when our index is even, we can take the square root or the fourth root or the 20th root of 0 and still get 0. But the moment we try to take the square root of a negative, we get into the world of the imaginaries. So the next couple of examples are going to restrict the domains so we don't have the issue of not having an inverse. So example number 7, given h of x equal to the square root of 4x minus 7 plus 1, we need to find the inverse. Then find the domain and range of each. So our first step, we're going to replace our function notation h of x with y. So we have y is equal to the square root of 4x minus 7 plus 1. Second step, we are going to switch x and y. So we have x is equal to the square root of 4y minus 7 plus 1. And remember that we are solving for y. It may help some students to rewrite this with our variable for which we are solving on the left-hand side. Notice that I didn't change anybody's signs, I just changed the order. So it's like I moved the equals x to the right-hand side. We need to get the radical by itself. So the first thing we're going to do is subtract the 1 from both sides. Now that we have the radical by itself, we can get rid of it by squaring both sides because my index is the imaginary 2. So I'm going to square both sides of my equation. If I had a fourth root, I would be taking both sides to the fourth power. If I had a 10th root, I would be taking both sides to the 10th power. On the left-hand side, my square and my square root take care of each other. So I have 4y minus 7 is equal to x minus 1 quantity squared. And keep in mind that we are solving for y. So we need to add that 7 to both sides. So we get 4y is equal to x minus 1 squared plus 7. And then we need to get the y by itself by dividing by 4 on both sides. So we're going to have parentheses x minus 1 squared plus 7 all over 4. And then our last step is to put our inverse notation. Since our original function was named h of x, we're going to name our inverse h inverse of x. And that's going to be equal to x minus 1 quantity squared plus 7 all over 4. We do not need to FOIL out the x minus 1 quantity squared and add the 7. If you wanted to, you could. You would get x squared minus 2x plus 8 all over 4. But again, you don't need to do that step. We're just fine with you taking x minus 1 squared plus 7 all over 4. So we still need to find domain and range. I'm going to go back to the little domain and range chart. That helps a lot of people with their organization. So my rows are going to be domain and range. My columns are going to be h of x, the original, and then h inverse of x, the inverse. Let's start by finding the domain of h of x. We have a radical function with an index of 2, which is why we squared both sides. And we know that 2 is even. And whenever we have an even index, we take the radicand, what's under the radical, 4x minus 7, set it greater than or equal to 0. For the domain, we do not care about that plus 1 at the end. We'll deal with that in a second. Okay. We have 4x greater than or equal to 7 and x greater than or equal to 7/4 when we divide both sides by 4. If you want to do a number line to help you with your interval notation, remember negative infinity on the left, positive infinity on the right. The only number we got going on is 7/4. We know that we are going bigger than 7/4, or since the x is on the left-hand side, the inequality shows us which way to shade. We have a bracket because the equal to under our inequality, and we get bracket 7/4 on up to infinity with a parenthesis, because your infinities always have parentheses, regardless if they are positive or negative. We just found the domain of the original, which means that we also found the range of the inverse. When we look at our inverse function, it looks like a polynomial, because it is, but it's an even degree. So we can't put in negative infinity, positive infinity, because we're going to have an issue. It won't be 1-to-1. We need to restrict the domain. With our radical function as our original, it's actually going to be nicer to find the range of h of x and then apply that to the inverse. We know that our original function for h of x was 4x minus 7 plus 1. And we know that starting out, if we plug in our x value from our domain, we would have 4 times 7/4 minus 7, and then our plus 1. This winds up giving us the square root of 0. Plus 1, square root of 0 is 0, which gets us 1. And again, I took our 7/4 from our domain, our starting point, and plugged that in. Okay. Looking for our range. So our starting value for our range is going to be 1. Well, let's say our starting or our ending. We need to figure out if our range is going towards the negatives or towards the positives. If we look at our function, we said our function was 4x minus 7 plus 1. We can also rewrite this as 1 plus the square root of 4x minus 7. I know you may be thinking, wow, that did a whole bunch. Well, I know on paper, not really. But conceptually, if we think about it, we're now starting at 1 and now we're adding the square root. We know that the square root is only going to be positive numbers. We can't have a negative, which means that we are going to get bigger and bigger. So if you keep plugging in values for x from our domain, our range is going to keep getting bigger because we are adding on that square root. If we were subtracting, we would be getting smaller, meaning we're going into the negatives. But here we're getting bigger, which means that our range, we're starting out at 1, and we're going on up to infinity. And we know that we have a bracket around the 1 because we actually got it to equal 1 when we plugged in the first x value, which is why we have that bracket. And then remember, infinity always has a parenthesis. And since we found the range of the original, we also found the domain of the inverse.